got some low-tech props there and low-tech handouts. Let's see. I'm Francis. I am a computer programmer, but that's not the topic of my talk. It's more about 3D data visualization. I'm a GIS certificate graduate, and full-time I'm a Boeing software engineer. This presentation is from my final project in digital cartography class. It was originally titled Physical Representation of Stratigraphic Unit Layers and Temporal Surface Data with a 4-Dimensional Paper Map. Now it's just called How to Build a Geotardis. One thing that the digital cartography class taught me was how to be creative and have fun with my maps. Okay. Let's see. My first inspiration for this project was from these 3D figures, or the one figure here, in the Arc Hydro books I was reading. Arc Hydro books are about hydrogeology and geodatabases for water resources. The figures display borehole wells and geological layers under the ground, and some other features like mountains in three-dimensional displays. The second inspiration for my designing a 4-dimensional paper map was the famous long-running British television sci-fi show, Doctor Who. Are any of you familiar with this TV show? Anyone else want to admit that they know about the show? Well, that's fabulous. Let's see. I was specifically inspired by Doctor Who's TARDIS. TARDIS is an acronym which stands for Time and Relative Dimension in Space. The TARDIS is the Doctor's blue police box. It's his spaceship and it's his time machine. Also, when you open the door, it's bigger spatially on the inside. My Geotardis, which is my final project, and let me pull one out here. So my Geotardis is a 3-dimensional paper map, and its acronym stands for Geographical or Geological Time and Rock Dimensions Information System. It displays surface features and subsurface geological layers on a 3D paper map. Also, here's a one inside a photo cube, and hidden inside the map is the 4th dimension, represented as a map flipbook. So if you remember these little map flipbooks that animate images on paper, it's a map flipbook that animates time series weather radar images of a storm passing over the same region. And finally, it has these fold-out paper wings that provide more information about the map. I found the 3D data and an article describing a workflow for how to create the 3D displays in ArcScene on the Alberta Geological Survey website. And my very many thanks to the author who I plan to send the Geotardis to. The primary data source for this project, the study location of the data is in a formation called the Peace River Arch up in Alberta, Canada. And the main data source is just simply borehole well locations with attribute values of their formation picks, or their elevation values of the top of each stratigraphic layer that well drills down into. In ArcMap, I first created an overview map showing the general location of the study area up in Canada, and this became the bottom of the map. a bigger version, simpler version of it here. So there's the bottom of the paper map. And then I created another map zooming in on the study area, and that became the top of my paper map. And that shows the locations of the borehole wells and some other landmarks. Then I got busy in ArcScene, which is ArcGIS's three-dimensional tool. I added the borehole well data multiple times so I could display the different layers in different colors along each drill well. And then I used the spatial analyst interpolation tool to take those borehole well data points and create raster surfaces from them. One raster surface for each elevation top. And then I added those raster surfaces to ArcScene and displayed them in 3D. And so in this figure, you can see all the borehole wells. And I should say this data was simulated data, but I've been doing it recently with real data in Missouri. And in that figure, you can see one elevation surface underground, and then another elevation surface of the ground level. Also in ArcScene, you can create cross-sections through these raster surfaces and also create geological unit solids of each formation layer. To create the sides of the 3D box map, I used a block diagram of the formation layers. And this is just 4 cross-sections through the underground layers that create a 3D square. Then in ArcScene, I set the view to look perpendicularly at the side of each side of the block diagram, and I exported that view to an image file. Then I brought that image file into ArcMap and converted it to polygons so I could symbolize it with geological patterns. All these different data views were organized in ArcMap's layout view, so it could be printed, cut, and folded into a 3D box. And this is one of the slides that sort of messed up, but I got a paper version of it here. So in ArcMap, I had 2 different layout views, one for one side of the box map, and then one for the inside of the box map. To create the temporal data map flipbook, I downloaded 160 weather radar images from for the study area that show a storm passing over the region. I needed enough images to make the little map book easy enough to flip through. Let's see. I had to create my own workflow because most of the time when you create map books in ArcMap, it's over different regions. But I wanted to create a map book over one region going through different time periods. So to do that, I put all the images in a raster catalog, added date time field values to its attribute table, and then used these values with ArcMap's data-driven pages to create a map book. And again, instead of creating a map book where each page is a different indexed location, and an example of that is this Missouri Atlas, where you usually get an index page showing you each page of the map along Missouri. So that's an index of a map, and then this whole thing is a map book where each page is a different location. But again, my map book had to be one location and then different images representing different time periods. I also heard Molly just recently did something like that, so I want to talk to you about how you did it. See if there was an easier way. And then finally I printed the map book out to a small size, so it was easy enough to hold in your hand and flip through. Finally, in my searches for 3D underground data, I found that there's an app for that. For what I was trying to do on paper, you can do with your smartphones. The British Geological Survey has smartphone apps called iGeology and iGeology 3D that display geological maps and also underground formation layers that are under your feet. That is if you're standing in the UK. I haven't checked if there's one for the US or anything. Also, I'm currently creating another Geotardis using some drill hole well data in Missouri. Thank you.